Okay, review number 5. There are currently 24,000 people in a rather large town. The town's population increases by about 150 people per year. After how many years will the town have 30,000 people? So my job's to find the number of years in this problem. So years is a unit and people's a unit as well. So X is the years and Y is the people. So per, and we would go people per year. Okay, the people per year is 150 and it's actual people. So it's a linear equation, not an exponential. So it's a straight line. So we got our beginning point, and from there we will be adding the repeated amount with X and then Y. Okay, so I know M is 150, and prior to the 150 we had 24,000. So pretty easy equation to write. So 24,000 plus 150 times X every year equals Y. And now I need to take these 30,000 people and put them into the equation so that I'm able to solve the equation. Okay, it's people, so that's Y. That's going in for Y, so I can just scribble that out. And X is only going to have one answer. We need to get the X by itself, so subtract 24,000. So 15X equals 6,000. And then I can divide both sides by 15 to give me my answer. So 6,000 divided by 15 is 400. No, it's 150. Sorry, I put 150. 150, 150, 150. And instead of 400, you're going to get 40. Okay? So 40 years. Sorry, that was a stupid mistake. Okay, number 2. Running a website has a startup fee and a monthly cost. Running a website for 4 months costs a total of $195. That includes your startup fee. Running a website for 7 months costs a total of $285, and that includes your startup fee. Calculate the total cost of running the website for 12 months. So I'm figuring out the cost. Okay, so the units I have are money and months. Okay, so months is X and money is Y. So dollars per month. Okay, dollars per month. I don't know that, but I do know that there is a dollars per month. Okay, so if I don't know that, the formula to find it is the Y minus Y over X minus X. Now, do I have enough information to find that? Well, yeah, 4 months cost $195. That makes sense. And then 7 months are $285. So I can use my money, Y is money, so I can use the two total costs, $285 and $195. It doesn't matter the order you put them as long as you match them up with the months they go with. Okay, so $195 would be 4 months, and then this would be 7 months. So this is going to be negative 90 over negative 3. Now, if you would have set them up in reverse order, it would have been 90 over 3, which is still positive 30. Okay, so it doesn't really matter the order they're put in. So the cost per month is $30. And that's going to be another linear equation. So XY plus MXY. Okay, so I know that M is $30. But $30 wasn't in the original problem. I found that out for myself. So I'm also going to need to use the Y equals M times X plus B to find how much money we paid before $30 per month. So we need a combo because I know my M's 30, but for X and Y I need a combo. Okay, they got to appear in the same sentence. So 4 months and $195. That sounds like a plan. And now y. Y is the money, so we're going to put $195 in for y. And then we're going to be taking our 30 times 4, $30 per month over 4 months. So I paid $195, and I had been paying $30 per month times 4, so that's $120 plus b. Now I'm going to put a 1 in front of that and circle it. And I need to subtract the 120 because the difference in these costs ends up being my startup fee. So 75 equals B. Okay, so now I can write my equation pretty easily. Okay, 75 plus 30x equals y. Now, in the last part of the problem, I need to find the cost after 12 months. So 12 months... that is going to go not in for y, but it would go in for x. So I don't want to put y here. I need to parenthesize x, scribble it out, and put 12. So that allows me to just punch. Y has one answer, and it's already by itself, so I can just plug it into my calculator. So 75 plus 30 parentheses 12 gives me 435. And that is my cost, $435. Okay, number 3. For Halloween, a person is buying Butterfinger and Reese's packages. Butterfinger packages cost 35 cents more than Reese's packages do. A person buys 14 packages, that's supposed to say 14 packages of Reese's. Sorry, I forgot that. Without me putting that there, you can't really solve it. Person buys 14 packages of Reese's and 17 Butterfinger packages, and they pay $97.40. Find the cost of each type of package. So I want to find out Reese's and Butterfinger, and I want to find their costs. So I'm going to put money labels right there. Okay, so I've got 3 units. I've got the Reese's, the Butterfinger, and then the cost. So that's 3 units, so we're going to want to arrange the information into a table. Total. I'm actually going to call this together. Okay. How many? And then the cost for a single unit, and then my 2 things, Reese's and Butterfinger. Okay, so the first thing, let's look at these first 4 boxes. It'd be the easiest way to go about that. Or actually, hold on a second. Put your total cost down here at the bottom. There's one total cost, $97.40. Now let's go up here and let's look for non-money amounts. The number of units, not the money. So I see 14's not money, and that's Reese's. Cross it out. 17's Butterfinger. Okay, you can add those and put 31, I guess, if you want. It's not really going to matter. Okay, now the only thing left about the money amount is the 35 cents more. So that means in these 2, you want to put x plus 0.35 and then x. Now, the Butterfingers cost more, so you want to put x plus 0.35 and then x, and then I'm going to black this out, okay? So I take 14 times x, 14x, and then I need to distribute the 17 to both your terms there. That's going to be 17x, and 17 times 0.35 is 5.95. Now, you have 2 like terms of x on bottom, so you don't need a second equation. You just need to add the x's together. So that's 31x plus 595 equals 97.40. So now I subtract 595 from both sides. So 31x equals... and I got 91.45. And then divide by 31, divide by 31. Okay, that's 295. So that's X, and X itself was under the Reese's, so 2.95 here. And then you don't plug that in anywhere. If you know that this is 2.95, then the other thing I didn't know is just 35 cents more. So I just take 2.95 plus 0.35, and I get 3.3, so that'd be $3.30. Okay, number 4. Darlene is making a quilt that has alternating stripes of regular quilting fabric and satin fabric. She spent $76 on 16 yards of the 2 fabrics at the store. Satin fabric costs $6 per yard, and the quilting fabric costs $4 per yard. How many yards of each fabric did she purchase? Okay, so I have 2 answers. I've got the quilting fabric. Now, I don't want to know the cost, so I'm not going to put the dollar sign. And then the satin. Okay, so then that's going to be 3 units because I've got my quilting, my satin, and then the money I'm paying for each one. So that's 3 units. So again, I want to arrange it into a table. Sorry, I'm going to start putting together. Okay, and then quilting and satin. So how many total costs do you have? You only have one, $76. So you put 76, cross that out. Now up here is the number of units you have, not the dollars. So that's dollars, so don't put those on top. You have 16 yards, but it doesn't state if that's for quilting or satin, so it's got to be the amount together. And so if I know the amount together, but I don't know the 2 amounts individually, I'm going to call that X, and that needs a different letter of Y. Okay, now here we're looking for dollars. So $6 for the satin, 6, and $4 for the quilting. And together, I'm not really selling any single units together, so black that out. Then I have 4X, and I've got 6Y. Okay, so I have a system here. I know that X plus Y equals 16. And I also know that 4X plus 6Y equals 76. So I need to use the elimination from the system. So I got 4, 4, 4, 4, 1, 1, 1. This is going to be 4X plus 4Y equals 64. And then 4X plus 6Y equals 76. Okay, so I make the bottoms all negative. The x's will cancel, and then I get negative 2y equals negative 12. So I'm going to divide both sides by negative 2, and y equals 6. So that's your satin. You have 6, and it says how many yards, so 6 yards of the satin. And then again, if you know that's 6, 16 minus 6 is 10, so x is going to equal 10. Okay, number 5. An antique car is currently worth $75,000. It increases in value. It's an antique. Those increase by 10% each year. How many years will it be before it's worth $100,000? So I want to figure out the number of years. And I have years and I have dollars. So X is years and Y is dollars. So per. Dollars per year. Well, there's no dollars per year. Instead, it's a percent per year. So it's 10%. It's 10% increase. Now, if it's not by $10, but it's at 10%, then it's not a straight line. It's going to be an exponential growth curve. So I know we have an initial amount, but from there I don't add. I will be timesing because you take units times percentages. Instead of mx, it's g. Now the times operation is being used here, so it needs to be repeated. So g to the x power, and then y. So I know you got 75,000 as your initial amount. Now we got to find our growth factor, and I find that by taking 100% and adding 10% to it. So it's going to be 110%. Move the decimal twice, and that's 1.10. Okay, so now my equation is $75,000 times 1.10 to the x power equals y. Now, $100,000 would be the number, the input number into the equation. But unfortunately for us, that's not x, that's y. So I need to replace the y, not the x. And now I got to solve for the x. So the x has one answer, but it is a power. So I'm not going to be able to just use the traditional methods of get it by itself. So I circle that. And I know that that power is always equal to the division of the logarithms. Change of base formula. And I know that 1.110 is my base. But before I know what goes on top, I'm going to have to divide out this 75,000. Divide, not subtract, because the opposite of multiplication is to divide. To undo a multiplication, you divide, not subtract. So I take 100,000 divided by 75,000, and that gives me 1.33. Okay, so I'm going to take log 1.33 divided by log 1.10. That's going to be about 3. 2.99 is practically 3, so 3 years. Okay, number 6. An internet service provider sells high-speed internet for $30 per month to 1,500 customers. For each dollar increase in price, the number of customers will decrease by 25. How many changes in price should occur before the company stops changing the price and maximize revenue, and what will the maximum revenue be? So I want to figure out basically at the end the maximum revenue. The other thing they ask for, you'll find, because you have to know that to find the maximum revenue. So maximum, don't draw those boxes, just draw a center arch, okay? And then know the point you're trying to find, and then how are you going to find that point? What's the formula to find that point for the x? It's opposite of b divided by 2a, not the quadratic formula, not the GCFT, none of that stuff. You got to get an equation, have a b and an a, and go from there. And to find y, you replace x on calculator. Okay, so that's for my opposite of b over 2a. Now, this is about revenue, so I know that revenue is the dollars I charge for something times the number of items that I'm going to sell. So revenue becomes y, and then I make a parentheses that represents each factor. So only dollar amounts can go here. Okay, so go find your dollar amounts. You have $30 and $1. Those have to be together. So $30 is your starting amount. Now, I know it says per month, but that's your starting amount. This isn't really a rate of change. I write 30. And then I'm going to do a $1 increase, but you see, I don't know how many dollars I'm going to add on to that. So that's going to be 1x. And then cross those out. Then I just put I was selling, when I did 30, I was selling to 1,500 customers. But every time I raise the price by $1, it decreases by 25, so minus 25. And I don't know how many 25s are going to be minus, so I need x on that. Okay, and then I'll need to do the FOIL so I can get x squared in x and then a constant. And I don't even really care about c. I don't need to use that. So I take 30 times 1,500, and then I'm going to take 30 times negative 25x. Remember, the 25x is negative. And then I'm going to take 1x times 1,500, and then I'm going to take 1x times negative 25x. Make sure that one with the minus in front of it, make sure those are always negative. So this is 45,000. This is negative 750 with x. This is positive 1,500 with x. This is negative 25 with x to the second. So I know negative 25 is my A. To find our B, we're going to have to add these two like terms together, and that actually is positive 750, and that's B, and then 45,000. Okay, now I'm home free. Opposite of B, remember this formula here. And then 2 and negative 25, which gives me negative 50. And when I divide negative 750 by negative 50, it's 15. Okay, so that's how many dollars are being $1 are being added on. So $30, I'm going to add $1 on 15 times. Now I want to find out how much money that makes me. So I put 15 in for the x's, and then it's just replacing those. Negative 25, x comes out, 15's in, second power, plus 750, x comes out, 15's in, plus 45,000. That's 50,625. And this consequently is the maximum revenue. Okay, number 7. A grenade is thrown upward into the air with an initial velocity of 200 feet per second. It's launched from a 30-foot high platform. After how many seconds does it land on the ground? So I need to figure out the seconds to this. Okay, I'm not finding a maximum, so it might, I know it's a parabola, but I'm not finding that top point, so I'm going to do some figuring here. It's x, it's y. Feet per second is 200. And it's a parabola, and I'm going to go from there. So it's a gravity, so negative 16x to the power of 2 plus feet per second is 200 with x. And you started from a 30-foot high platform, so 30, and then equal it to y. Now the ground is 0 feet, okay? So if it's 0 feet, feet's y, so I'm going to be putting it in for y. Now this time the x is to the second, so there's going to be 2 answers I have to find for x now that y has been taken out. And I'm going to need to do factoring because I've got second power and first power. And it's easy to see it's 3 terms, so GCF and T. So GCF, we do have a negative in front. We don't have x on everything. Now let's look at 16. 1/16. 16 divided by 2 is 8. 16 divided by 3 is a decimal, and 16 divided by 4 is 4. As soon as I get twin factors, I'm good. Now let's see if we can divide these all by 16. Well, I know I can divide 16 by 16, but not 200. Okay, now let's check out 8. 16 divided by 8 works. 200 divided by 8 works, but does 30 divided by 8? Nope. Let's check out 4. That worked. 200 divided by 4 works, but 30 divided by 4, no. Okay, let's try 2. Now, are all these even numbers? Do they? Yeah, they are. So you know 2 is going to work for sure if it comes down to that. So negative 2, divide all your negative 2's. So that's positive 8 with x second, minus 100 with x, minus 15. Okay, so I'm going to take a times c, so it's going to be 8 times negative 15, and that's negative 120. I really don't like doing T-charts with numbers in the hundreds, so I'm just going to skip that and do my quadratic formula. So the opposite of b is positive 100, square root, parentheses second, minus these 3 parentheses here. Okay, so b is negative 100, and then 4, a is 8, and c is negative 15. Then I'm going to have 2 and 8. Okay, so I know I got the 100. Square root I'll figure out in a second, and 2 times 8 is 16. Now plug that in. So second square root, remember you want 2 parentheses at the beginning if you're going to use the calculator. take 100 to the second, minus, parentheses 4, parentheses 8, parentheses negative 15. 102.37. Okay, so 100 plus 102.37 divided by 16, and that's going to be 12.65. That's a pretty good looking answer. Then I take 100 minus 102.37, hit equals, divided by 16. Negative 0.15. Well, this looks like a more logical, reasonable answer. So there you go.